Waiting for your intro song to end.
Yeah, I'm really jamming to this. So.
But just go ahead and let them know you're ready to go.
All right, hello everyone. We are the In-Working team, and we were tasked with working on a maintenance cockpit in the MyCannageeser portal. My name is Connor Fradenberg.
I'm Derek Boonstra.
I'm Tanner Olson.
And I'm Victor Oda. We'll begin by examining our sponsor, In-Working. In-Working is a company located in Germany. They generally deal with business software development and consulting. They're an official SAP partner, and they have many large clients around the world, such as Volkswagen and Adidas. In-Working was contracted by Cannageeser to develop software, as with much of their work. Cannageeser are a leader in industrial laundry technology. They have customers in 51 countries all over the world, and currently they are In-Working's project customer. Cannageeser was interested in a portal or a prototype for a new customer portal that is subject to further change. The new features that were needed in this portal were a maintenance cockpit where users can perform maintenance tasks or activities on their machine, detailed views for both orders and machines, and the ability to filter or search items in views. The solution by which this would be done would be to provide a easy-to-use interface with streamlined navigation. There'd be two distinct views in the maintenance cockpit. The first of which would be the order view, which customers can view their orders. They can view details regarding the machines in the orders, and they can view tutorials and information on their machines. And the second view, which is very similar, would be the machine view, and the customers can view their machines and what orders are attached to the machine, and they can perform maintenance tasks on these same machines, in addition to be able to filter/search through a list of them. Tanner will now discuss our project scheduling.
As Victor was saying, we were working with the team in Germany, In-Working, Maxim Reagan and Bastian Bachmann, and we had our weekly Skype meetings at 8 a.m. our time, when it was 3 p.m. over there. About halfway through the semester, we decided that just having a weekly meeting wasn't sufficient. We wanted to streamline our communications, so we set up a Slack server, and that smoothed things out very nicely. We were working in parallel. We had the front-end web UI to work with, and they worked on the database backend. Throughout the semester, we started out working on a tutorial to get familiar with the environments. We set up all sorts of different views that were required, and towards the end of the semester, we worked on some nice-to-haves, such as the feedback page and the maintenance video viewport. Sprint 1, we developed user stories, got familiar with each other, introduced ourselves. We set up the project specification document and learned with the SAP UI5 tutorial, which taught us quite a bit that we used. We began working with the Build Me. It's a rapid prototyping website specifically for UI5, and it was very nice to work with. But during Sprint 2, we wanted to get off of that and actually work with the web ID provided for us. With Sprint 2, we also implemented some mock data for the midterm. Sprint 3, we implemented an actual database connection. We worked mainly on the web ID, and that went pretty good. Sprint 4, which is recently, we worked on implementing additional views and setting up routing between them. Progress so far, we've got a login page that allows us to access the maintenance cockpit, which splits there between the machine view and the order view. They both display master lists they have test data that's interactable, and all the order and machine information is displayed. Connor will talk about that in a moment, but we also had some additional views. I started with the feedback page. We added a button to each page to route there, and just due to lack of time, it lacks interaction with the database. And then Derek worked on the video page. Do you want to talk about that?
The videos were transcribed in both English and German, but we had some issues getting the MP4 to display in XML.
And now Connor will show you quite a bit of our project through our demo.
All right, so for our demo, we decided to do pictures instead of a live demo because we were working with the SAP Web IDE, and to kind of run the website with the mock data, we would have to run it through that. There's kind of be some issues with that possibly. So just using some pictures. The first thing that it takes you to is a login page. Now originally we wanted to have 2 different users that would have access to different data, but unfortunately we weren't able to really implement that with the data that we had, so we just forgot about that. And so for right now with the login page, you can enter anything because validation wasn't too important for us. And after you enter in a username and a password, you click the login button and it brings you directly to the maintenance cockpit, which is right here. And with the maintenance cockpit, there are 2 different buttons. One on the left has a button to go to the machine view, and one on the right is to the order view. Now both of these buttons display how many machines or orders there are. So for us, with our data, we have 715 machines and 12 orders. Now I know it's a little bit hard to see, but underneath that that number, there's a thing that says the critical section, so there'll be any critical orders or maintenance that needs to be done. Now one issue that we had that I'll talk about a little bit later is Cannageeser didn't actually give Inworkin or us access to their database, so Inworkin had to create the data themselves, and because of this, some properties that we thought would be in it weren't actually in it, so this is more just showing what could be done. Now once you click on either of these buttons, they will take you to their respective views, so we're going to start out by checking out the machine view. So with the machine view, on the left there's a list that displays all the machines, and this shows the description of the machine and the number. Now as I said before, Inworkin had to create this data, so a lot of it's similar with just a little bit changed. At the top of the list there are 2 buttons, one titled Goods Recipient and one titled Filter. The Goods Recipient button would change the location of the machines that would show to the user, and the filter would just filter through. Now unfortunately, with the way that our data was set up, neither of these buttons were working. There's also a live change search bar, so the user can enter in anything with relation to the equipment number or the description, and it'll change based on what they entered. So for example, if the user enters in the numbers 0026, then they will be shown that only one machine fits that, and that is the workflow machine. Now after the user clicks on the list, the item in the list, then they will be shown a detail view that goes more in depth about the machine. So at the header, it has the description name, equipment number, construction year, and how long the warranty will last. And the rest of the page just has any orders that a machine may have with it. And the orders will show the description, equipment number that is, or the order number that the order is for, and what date it is due on. And at the bottom of the machine list, there's a button so you can switch to the order view for seamless navigation throughout the pages. So we're just going to pretend that we clicked on that, and it's going to bring us to the order view. Now the order view is very similar to the machine view because we wanted to make this as easy as possible for a user so they don't have to learn a bunch of different things and they can tell what to do rather easily. So this list will display any orders and some data about the orders. It shows the order number, description, the due date for the order, and what equipment number the order is for. There's also the same buttons, but unfortunately those don't work either, and a live change search bar. So I'll show you a little bit more with the search bar. For example, on the left, it shows that the user entered in the word drive, and it comes up with the orders for clean, check, and tighten the drive belt, and change the drive belt. And on the right, the user entered in the word vent, and they were shown orders for clean ventilators and suction shaft, and check cylinder, ventils, and pipelines. Now again, similar to the machine view, once somebody clicks on an order, they are given more information about that selected order. It again just shows the order number, description, equipment number, and what date the order is due on. And then the rest of the page shows any maintenance steps that a user must take to complete the order. So with these maintenance steps, it shows the code for the maintenance, what equipment number the maintenance step is linked to, and a description of that maintenance order. On the right side, there are little check marks for done, but again, due to issues with the data, there wasn't any actual property for a done maintenance order, so that's more just to show what can be done. Now I'm going to talk a little bit more about the user story points. So with this graph, the purple line shows all of our user story points, including the nice to have. The red are the required story points, and the black are the story points that we completed. Now, as you can see, we completed all of our required story points and worked on some nice to have. But you can tell that at about day 60, we realized something was horribly wrong, and the progress that we thought we made, we didn't actually make. And this was due to the way that we had to implement the data. We thought we were implementing it one way, but instead we had to create a mock server and do kind of some stuff with that. Thankfully, we were able to get that figured out and then move on to work on some nice to haves. Now, a lot of the nice to haves weren't fully completed, but more prototypes of what we could do. For example, a video page that Derek will be talking about in a little bit. But that's about how our user stories went. Now I'm going to talk a little bit more about some of the issues and risks that we faced. One of the biggest issues with this project was that there were 3 parties involved. It wasn't just NDSU and Inworkin, but also the Cannageeser company. Now, Inworkin worked directly with Cannageeser, and there just seemed to be a lack of information from Cannageeser to Inworkin. So of course there was a lack of information from Inworkin to us that kind of made it hard for us to understand exactly what we needed to do for the project. In addition, as I've been mentioning, we never got access to the Cannageeser database, so we didn't know exactly what different properties there would be, and instead we just had to work off of the metadata and database that Inworkin created for us. Now, another large issue that we had was the time difference between our 2 teams. As we stated before, we would have our Skype meetings at about 8 a.m. for us and 3 p.m. for them. But one of our biggest problems was that a lot of times when we would be working, which was either in the evenings or on the weekends, that's when they would be asleep. So obviously, if we have a problem and we can't move on without fixing that, we would have to ask a question, and we didn't expect them to answer it right away. So we would have to kind of stop all progress for the night and wait until the next day to figure out our problem. Working with the build.me, it was nice to start with to kind of design the UI, but after we moved off, we kind of realized that we relied on it too much and we should have moved off of it much sooner than before, because it built a lot of the stuff, but it built it incorrectly. For example, when we created our mock server, once we got it from the build.me, there was 1,000 lines of code, when in reality we only needed about 30. So that was just kind of confusion due to that. Another issue that we had was the Web IDE and the SAP UI5 are rather new technology, so there's not a lot of information about it. If you have any problems with it, you might get 2 or 3 results that don't directly correlate to it, so you have to kind of figure out what exactly the problem is and how to fix it. This was a problem with the video tutorial and feedback implementation that we had, and a very large problem with displaying the mock data, and finally the routing issues. Routing to different pages was another issue, because we found that we had to combine everything together more so to route it, so that kind of took a lot of time. And the last risk, I'll let Derek talk about since he knows a little bit more about the video implementation.
Some issues with the video implementation is XML doesn't support videos, so you have to contain it in an HTML block. And we were facing some issues with that because we tried to put it in panels or pop-up windows, and it was still reading it as XML data, which would just end up breaking our code. And so we tried to just display it as the HTML code, and then moving it into the Web IDE as well. The files were actually too large and the Web IDE wouldn't take them, so that was another issue we faced. Moving into the postmortem, what we learned was working with an international team seemed very beneficial. As we move on after graduation, we'll be put into many teams, and I don't think we'll run into any more difficulties than we faced working with a team across the world. Also, XML and SAP UI5 were new to all of us at the start of the semester, so we had to go through a lot of tutorials and documentation to begin the semester to start working with this stuff. What went well was we completed all of our must-haves, and they all are bug-free. Everything works on the web page from the required stuff. And then what went wrong was implementing the mock data took a lot longer than expected. Inverkin had to wait on Cannageeser for some of the data, and then they ended up just creating it themselves, which ended up taking a while. And then our nice to haves and the views took a lot longer than expected, and the time constraints made it so we weren't able to finish all of the nice to haves that we wanted to. Some of the next steps for our project would be to finish the nice to haves, the video implementation, and the feedback section. Also, adding multiple users to the login page would so then users could have specific orders assigned to them in the cockpit. Also, Inverkin will go to Cannageeser to present the prototype. They'll get input and feedback from them on what they should add and take away from the prototype. Also, develop a portal based off the input from Cannageeser. If Cannageeser likes the prototype and it is successful, it will be implemented into Cannageeser's live servers, and that does not currently have a maintenance portal, so it would be a good addition to their cockpit.
And that's about it. Does anybody have any questions?
Have you looked at this on multiple browsers?
Yeah, it works on Google Chrome, Firefox. We didn't really check Internet Explorer too much because it's Internet Explorer, but Google Chrome and Firefox works within the SAP Web IDE. All right, thank you.
Thank you.
Hi everyone, we're Fjord's team. I'm Zachary, this is Aaron, Ben, and Stone. Thank you for coming to our presentation today. All right, quick word about our sponsor really quick. His name is Tim Barsness. He is the president of the company we work for, Fjord. He graduated from NDSU with computer science, and then he hired his first employee senior year of college, and it's grown into the business that he has currently. Tim, it's been really great working with you. We really appreciate all the help you've done with us, meeting with us weekly, and then outside of the times we set aside, it's been really great. So big thank you to you. Moving on to the presentation here, here's a couple things we're going to talk about, going over what Fjord is, talk about the problem Fjord had, and then the solution we had. We're going to demo the solution, talk about what kind of things we thought in retrospect, and then look at the next steps. So, for those of you who don't know, Fjord is a company that works with customized web applications, and that deals with browser applications, that deals with mobile applications, anything that works with the client's website. They work with that. They work with developing websites, but they also have maintenance plans where they can work on hosting, updating, and backups, that kind of stuff. So they work with all sides of the websites. Fjord has grown a lot in the past year or so. They were at 23, and then they moved up to 30 employees, and it's only grown up from there. Again, they work specifically with website development, but they also do some other interesting stuff. Like one thing I found while I was searching their website was they had podcasts, and it was like weekly, bi-weekly, and those podcasts were dedicated to working with the advertising industry and talking about different trends and that kind of thing, working specifically for their clients. So I thought that was kind of cool. But with the amount of growth that they've had a lot of growth in projects and other things. So their accounting and billing workload has almost doubled, and I'll tell you why that's a problem in a second here. So some of the things that we worked with specifically was Harvest, Google Sheets, and QuickBooks. Harvest deals with their projects and all the different things they do with their project, the time spent, so they're logging information. Then there's the Google Sheets, and that's where the employees go in and say, this is what I'm going to be working on today, this is what I'm going to be working on tomorrow, these are the projects that I'm going to be putting time towards. And then QuickBooks is all their finances and that kind of thing. There's a bunch of other things that they pull data from, but at this point, that's what we worked on specifically, those three. So moving on, we're going to talk about the problem here really quick, or the opportunity, if you will. So the problem that Fjord had was, with all that growth that they've had, there's a lot of reports that they have to create. So the amount of time that they spend on reports, there's a lot of numbers that are up in the air. So they had to have a team sit down for hours upon hours each day and create all those reports manually. Obviously, that takes a lot of time. I don't know if any of you have done many reporting, but it takes a lot of time to do that kind of thing, especially for large amounts of data. And the amount of projects, it just didn't make sense for them to continue doing it manually. They did look at a third-party software called Zapier, but it didn't quite fit their needs. They needed to have a little bit less constrictions, I should say. So they wanted to move on from that manual reporting. Here to talk a little more about the solution is Stone.
All right, thank you, Zach. So I'm going to talk about the solution. So the name of the solution is called the Grand Central Database. As the name described, if you want to keep their data in like one database, it's this Grand Central Database project. And as we mentioned before, they're not only doing the manual reporting, they're also manually import data from QuickBooks and Google Sheets into their database. So that also takes a lot of time to do it. So the point of this project is to import all the data from different places into one database. And based on those imported data, we could make different specific reports that can help their company to manage their resources. And we're not the first team that worked on this project. This has been started like 2 years ago. 2 formal teams has worked on it before. And before we start to work on it, a database has already been built. And of course, there's our website interface that you can view all data from the database. And also, the former teams worked on the imports, and they also make the code of the import section more extensible. So we can keep working on it and add on to the existing imports. And here's the overview of our project. So at the beginning, our first goal or task is to create all the reports that you can see here. We're going to go into a little bit detail later in the demo, but as you can see here, all the 5 reports are the tasks at the beginning we're asked to, and after midterm, we add on a little bit work to create the imports. And now let's take a look at our schedule. So this is basically the first half of the schedule. So this is what we've done before the midterm. At the beginning, we get all the software installed and the environment set up on our local device. And then we start to import the data to our local copy of the database so we can start work on it. So we did have a little bit of difficulties on it because it's an existing project. So we did have some errors. And so it takes some time, longer than we thought, to fixing those errors. And also, need to mention that again, Tim was really helpful. He had a lot of extra meetings with us during the first couple weeks. And then we get and then we start to work on the reports. So the first reports we made with the maintenance budget report. It says maintenance account status report here. And the first one, because we were not very familiar with the .NET Core Entity Framework and the link query operation, so we spent a little more time on it to learn how it works. So that's why it has more story points than the others. And after we get the first report running, and the rest came a lot faster. But at the midterm, we pretty much finished most of the reports we asked to do at the beginning, so we were ahead of our plan. So we talked to our mentor after midterm, so we make some new plans. So here's basically what the new plans we got after midterm. So the most important part is we're gonna start to create all the imports, especially the Google Sheets import and the QuickBooks import. And also we got 2 new reports. It will be based on the new imports we made. And here's the second half of our schedule. So you can see here the first reports is called the utilization billable rates reports. It's based on the new harvest import we add on to the existing harvest import. And also we start to work on the Google Sheets imports and the QuickBooks imports. We're going to talk a little more about that in the demo later. And then the schedule hours reports is also based on the new Google Sheets imports we made. And the last two reports you can see here, there's parentheses at the end, says NC. It means not the starter points are not calculated towards our progress or velocity, because to build those reports, we're going to need more data from the reports, from the imports. So they're going to need to be made after all the imports finished, and also those reports need to have more information from the Fjord company. So those were not committed to our task. All right, now let's move on to the demo. Everyone will show the demo.
All right, so now that we kind of talked about the reports we worked on and what we've added onto the project, we're going to give you a demonstration and show you what it actually looks like and what we accomplished. So when you load up the app, you get this home page that shows the same graphic that was in an earlier slide, just kind of giving you a brief overview of what the Grand Central database is. And then you get these tabs at the top: Home, Projects, Customers, Employees. The projects, customers, employees were there when we got the project. Those are just kind of directly ways to mess with the data in those tables. But what we worked on were the reports. So if we click on that, here's the 5 reports we created. I'll talk about each of them a little bit, but we'll go a little more in depth into the first one, the maintenance budget report. So this was one of the first reports we created, and it's based on the maintenance plans that Fjord does, as we talked about a little bit at the start of the presentation. What that is Fjord also does monthly maintenance for different companies on their websites, whether it's backing up data or backing up the websites, hosting data, doing upgrades, etc. So they have these plans with companies that every month they have a certain amount of hours budgeted towards those projects. And this report, what it does is it takes that budget of the hours they have every month and it compares it towards the amount of hours they actually spent on it for that month. So by looking at that, you can see the remaining hours they have. And then the 3-month and 6-month columns are an average of the total hours spent based over those time periods. So you can tell if a project was over budget, you can see if it was just kind of a one-time thing or if it's something that happens more often. At the top here, Zach's going to click on this arrow. You can go left and right between different months to look at the report for different months, and it's just the same thing, but it's those same maintenance projects for that month. So now this is valuable to Fjord because in the past they used to manually do this every single month, whereas we can just click a button here and get the report in a few seconds. So if we go back to the reports, now we can look at the over budget report, which is kind of similar in a sense, but it has to do more with all the other projects that aren't maintenance. So these don't have to do with a date range because they're just, once you get a project, you do it until you're done. It's not monthly or anything like that. And it's a similar kind of thing. It takes the budgeted hours and then compares it with the amount of hours they put towards it, which is the sum hours. And then you can calculate how many hours they're over budget, how much % over they are, and then the total over is actually the money that it costed them by going over budget multiplied by the hourly rate that was set on that project. So now if we go back in the reports, we can look at the project profitability. This one deals more with projects that are already completed. It takes a little longer to load because we had to do some more work on them, it looks through more data. But it takes projects that are already done and it calculates the budgeted hours towards them multiplied by that hourly rate that we saw in the previous report and compares it directly with the amount of hours they spent on it with the average cost per hour it costs Fjord for an employee to work on it. So by taking that, you can calculate the total profitability of those projects. If Zach scrolls down here a little bit, you'll see some rows are red, and that is because there's some projects that Fjord has data for that doesn't have an hourly rate, and that could be from a couple different factors. For example, a project was internal, so it wasn't from a customer. It was just something Fjord was doing internally for themselves, so it wouldn't have an hourly rate. Or it was just a bug in data entry, so either way it's something you want to flag, and because the profit is going to be messed up, and that's why we don't even display the profit on those ones. Now if we go back in the reports, we can look at the scheduled hours. Now the first 3 had to do with the harvest data we already had imported in when we received the project. But the scheduled hours has to do with the new Google Sheets import that Zach messed with a little bit. And you'll get to see what that sheet actually looks like in a little bit. But basically, it's kind of like an Excel document, and it's where employees can go and input what they're dedicating their hours towards, what projects. And this report basically lists off all the projects, and it shows in the coming weeks how many hours are dedicated towards them. The column at the top is actually all the time not dedicated to a project yet. It's very large here because this is actually using some mock data that we received from Tim. And in a real example, there wouldn't be that many hours not dedicated. It just wasn't completely filled out. The actual data will be there eventually, but the report that Zach was working on did not get completely finished. It was nearly at that point, but not completely finished yet. And the last report we worked on was the utilization billable rates report. And this one had to do with the other tables we added onto the harvest import that was given to us at the start. As you can see, there's no data here right away because it's the start of a new month. But it has the same kind of parameter as the maintenance budget, so we can go back a month and look at that. This shows all the employees Fjorge has, and it shows their hours they have spent on projects and tells you how many of those hours were billable, and that's what the utilization percent is. As you can see, some have a utilization of 0%. For example, Tim at the top, and that's because Tim's the president. He's not going to be working directly on projects that are billable and have money going towards them. He's doing more just overview of the company. Whereas you have other ones that are higher utilization because those employees were working directly on projects. But basically, those are all the reports we finished and have to show you today. And now Zach and Stone are going to each talk a little bit about the imports they worked on.
All right, so as Aaron mentioned before, I worked on the Google Sheets import. And basically, as you can see there, it's probably kind of hard to see, but it's basically, there's just a bunch of information about people, the amount of hours they worked on it, and then exactly what projects they worked on. And this is all being compiled into one database. What it's using is using the Google Sheets import, or the Google Sheets API, I should say, to take all that data and throw it in the database, basically. I got fairly familiar with the API. It took a little bit of time, but I've been working with APIs for a while, so I know kind of what I'm doing. The interesting thing, though, was that I know it's hard to see, but on the left there, they have starting points for a bunch of different languages. So browser, Java, iPhone, iOS, that kind of thing. However, we were working in .NET Core, which is a fairly new language, so they didn't have any documentation on that. So we had to kind of research outside of the box. I had to kind of look at different things to figure out how to get through. We did get past that, or I did get past that part. Was not able to finish it completely, just due to running out of time with how much stuff I had to do. However, both me and Stone, we both took all of our data because it wasn't fully complete. We took all of our information, just threw it in documentation so they can use it later, either next capstone teams or whoever else is going to be working on that next. So if Stone wants to talk about his QuickBooks real quick.
All right, so QuickBooks Online API is pretty much an application that can help company to manage their workflow, and also in our case, it's helped the Fjorge company to manage their accounting information. As you can see here, it's just the interface of the QuickBook Online application. And what we need to do is to connect, also just like the QuickBook, like the Google API, QuickBooks has their own API. So what we need to do is connect QuickBooks API, their application, using OAuth to our database. So, yeah, as you can see here, those are the tokens and keys we're going to need to connect the QuickBook API to the project. So you can just use the online playground to generate all these tokens. And after you get it connected, you can see using the QuickBook.NET Core client, you can pull data for testing. I'm using like a sandbox company that Fjorge gave me that has some dummy data in there. So as you can see here, it pulled. This is the example of all the customer information that pulled from the sandbox application. So go to a little bit details. If you expand one column, you can see all the information about this specific customer or company. So using the same way, you can pull all the data you need from the QuickBook application. And as we mentioned before, this is not complete. All the imports are not completely finished. So we're gonna commit our progress towards the project and documentation, and put this documentation so the future teams can extend the existing import or keep working on it. And moving on to Ben for the review.
Well, there were some issues when we were going through this project. One of them was that I had some trouble connecting to the database for a while, but I was able to connect eventually. But originally, I mainly focused on documentation. But once I was connected, I was able to use a virtual machine and make an extra import for harvest. Another issue we had was transferring SQL to LINQ code. It took us a while to figure out how to get that working. Also, after the midterm with the new requirements, one of the things we had to do was make new imports, and that was something that was new to us. So we had to learn how to do that. Although we did overcome all these things eventually. And for the postmortem, in retrospect, what went really well this semester was making the various reports. I mean, we got quite a few done, and it went quite smoothly. And also getting the system ready for Google Sheets and QuickBooks. Even though we don't have it fully implemented yet, we do have it ready so that it could be picked up in the future, perhaps with another team or Fjords themselves. Also, the communication amongst the team and the sponsor went quite well. We worked pretty well together, and the team worked at a pretty steady pace as well. And though there were some things that didn't go so well, these are pretty much the things that I mentioned before. What we learned during this capstone was lots of great experience in software development. We got to see what it was like to actually make something that would be used in the real world, and also what it was like to work for a sponsor or boss. And also, as far as what we would recommend for future capstone teams, we would suggest going over the previous capstones work if there are any, so you can pick up where they left off. We also recommend setting time aside ahead of time to connect with the program that you're going to be working with. As far as the next steps in this project, one of the next things that can be done is to make more reports. I mean, especially for the QuickBooks and Google Sheets, once that is implemented, as well as additional reports that Fjords might need in the future. Also, additional imports could be made to get data from other programs that Fjords uses, like HubSpot, which is one that we've heard they use. And also, the current reports can be added onto with additional variables and filters and just other ways of calculating the data. And in conclusion, the capstone project has gone very well. We have a good amount of code and deliverables for Fjords, and we hope Fjords will benefit from what we've made just as we have benefited from working with them. Are there any questions?
One offhand, the screenshot of that QuickBooks token, that's just an example demo one and not specific to this company, right?
Yes.
It is actually the token of that sandbox company.
Okay.
So, and I forgot to mention that's the sandbox company was made was an old one, so it was still using OAuth 1.0. But the QuickBooks, they already updated to OAuth 2.0, so the tokens are actually changed. I'm not sure. I think the new application you made on QuickBooks, they're not gonna generate the same tokens same as the 1.0. So if they're actually gonna implement that into like an actual app, it's gonna be needed to switch from OAuth 1.0 to 2.0.
You had some reports that were done early. Did you actually deliver those so they could start using them ahead of time? Or?
Tim's had access to our code the whole time. I guess he's kind of been working pretty closely with us on it, so if he ever wanted to, he could have used them at any time, I guess. I don't believe he's using them yet, but...
They're in a staging right now. We haven't deployed it.
Okay. I was interested to see that Tim's working 55.5 hours a week. Probably above what a startup company as well as a startup. Actually, since Tim's here, I actually have a question for Tim. Have you ever thought about turning this whole thing into a product?
Kind of. I think.
It seems like it could be.
Yeah, right. Yep. I think there's something to do. Try not to take mine out of the ball right now. Just keep doing what we're doing.
Yeah.
Anything else, or anyone else? Cool.
All right, thanks.
Thanks, guys. And that's done.
Hello, everyone. Thank you for coming. We are the Arete work group, and we are developing a help desk chatbot. My name is Brian Engelbrecht.
My name is Jesse Kunze.
And I'm Andrew Zinke.
So today we're going to go over a few things with you, give you a little overview of the company and what they do, talk about the problem they had and then the solution we came up with for it. We'll go over the schedule that we had planned out for the beginning of the semester. Then we'll talk about the progress we had throughout and then our current status. We'll give a demonstration of the project so you can see what it looks like from the user's perspective as well as the help desk agent's perspective. We'll discuss some of the risks and issues we encountered along the way, give a post-mortem summary of how we think we did overall, and then discuss some of the next steps we think would be good for future development of the project. So Arete is a consulting company that helps clients implement ServiceNow. And this is basically a service management software that can be summarized as a ticketing system. And what that means is any user who has a problem or a request for help can fill out some details, make a report, and then send it in. And then the help desk agents can go through these tickets, figure out what these users' problems are, forward them to the correct department that can help them out. And then it's that process over and over. So it fills up, and then they clear them out, and that's how they can manage how well they're serving their customers. Our mentor is Chris Richter, and he has been a great help throughout this entire process. So what Arete needs is a chatbot to act as a frontline for their technical support group. As you can see in the diagram here, it's actually a very simple setup. The end user will interact with the chatbot. It will get some details about what issue they're having, and then it will create a report that is then sent to ServiceNow and stored as a ticket. And then ServiceNow will categorize it, but then it can be used by the help desk agent, and then they can read it, see what the deal is. They can contact them, stay in contact with them, and then eventually just get them the help that they need, and then close the ticket. The chatbot should talk to the user to determine their issue, and then once it has what it needs, provide the user with a solution. Now, this can happen one of two ways. First is just get the details that it needs, create the report, and send it to ServiceNow. This will actually happen in every instance, but in a case where their problem is rather simple or there is a knowledge article that can allow them to just walk through and read, figure out the problem for themselves and fix it, avoiding any further contact with a live agent, it will do that. So it will add a link into its own actual chat bubble and then provide it that way. So there's a faster and then a longer situation here, but in the end, it will always get them the help that they need. So the tools that we selected to use for this project that we thought would make it easiest to develop was the Microsoft Bot Builder SDK. We paired this with Node.js. Our other option was C#, but our teammate Jesse had some experience with Node.js and assured us that it was pretty easy to work with and learn. Microsoft Bot Builder also had a great length of documentation that was easy to read and learn, and based on how it was designed, it seemed like the best implementation for what we were trying to create. We also used the ServiceNow developer instance for testing. This was included with ServiceNow's website. It basically allows any developer to have their own miniature database that receives all the reports they generate with the chatbot that they're developing, and then they can go in and see if it's getting any errors or it's not filling in fields correctly, and they can fix it that way. So a dialogue is the main part of the MSBot framework. You'll hear us talk about it a lot, so I thought we should just show what a single dialogue looks like. You can basically break it into just two functions. The first one is the prompt that it gives right away. So this is what the chatbot itself is saying, or in this context, asking. And then the second function is after the user's input, and they have responded to the question. And the code, which we've cut off for the sake of the screenshot, is basically all the code that will determine what it does after it registers their input and figures out what exactly the user had said. So now I'll pass off to Andrew, and he'll discuss the schedule and give you a brief demonstration.
So for our schedule, we've had it planned out pretty much from the start. We broke it down into 4 sprints of about 3 weeks long each. For our first sprint, we wanted to have each of us research individual chatbots and then come together as a group so we could decide on which one would be best for us to use. We ended up deciding on using Microsoft Bot Builder, as Brian said. And then we wanted each of us to create a basic chatbot on our own so that we'd have basic understanding of what to expect when working with the chatbot in the future. In sprint number 2, we wanted to have the chatbot be able to parse through user input and detect keywords. And when I say parse, I mean have it go through the initial conversation that the user input and look for specific words that can help it go through the decision tree, which is another thing we wanted in sprint number 2. And the decision tree was given to us by Chris, and what it is a 3-level tree with keywords at each level to help categorize what the issue is. Level 1 being something as broad as instant or request or a password, with level 2 being a little bit more in detail, talking about whether it's with an email or database or software. And level 3 being what the actual issue is, saying it won't start, or I can't get into it, or I'm having issues updating my database. In sprint number 3, we wanted to be able to have the chatbot generate full reports using ServiceNow. And with the full reports, we wanted it to fill out things such as who the caller was, what the category and subcategory are, and a full description of what the problem is. We also started working on embedding the chatbot at this time, and we wanted to embed it into a web page so it wouldn't just be a bot emulator. And for our 4th and final sprint, we started looking into AI implementation with Lewis, and also looking into keyword pairing. So for our current progress and current status, we have finished the report and ticket generation. The reports get fully filled out based on what the user inputs. We have started working on embedding it, but we are running some issues that Brian will talk about later. We have looked into a possible Lewis solution. Brian will also talk about that in the future. And we have started working on upgrading a single keyword system into the keyword pairing. And what the keyword pairing is a way for the chatbot to be able to pick up multiple keywords at once so that the user doesn't have to go through each level in the decision tree one at a time. The keyword pairing is supposed to make it so the user has a more fluid experience with the chatbot. Say they put in, I'm having an issue with my email. It'd pick up both issue and email and send them straight to level 3 and give a proper prompt to get the last remaining keywords, such as, having issues starting up, or is it a logging in issue, or something like that. We've ran into a lot of issues with this keyword pairing, a few of them being that some of the keywords at the level 2 and level 3 in the decision tree, they were the same even across layers. So we had to make the language more apt for each situation. We've also have a current issue right now where if they stop with a level 2 keyword, say they put in a level 1 and a level 2 keyword, the level 3 keyword gets picked up at random. We've tried changing the keyword just to something that will never be input, and it still gets picked at random. So we're trying to figure that out still. Our current style implements a sub-parsing function. So what I mean by that is when a keyword is found in level 1, it'll call the sub-parsing function to look for another keyword in the level 2. And if level 2 keyword is found, it'll continue on to level 3. So now I'll give you a live demonstration of it. So just swap on over to the emulator here, and you can see it's already been woken up. You just type in something like hi, and it'll say, thank you for choosing Arete. What is your full name? I'm just going to input a name here that's already associated with ServiceNow, and it'll say, nice to see you. How can I help you? So I'm just going to show you a basic one that just goes into one level, and I'm just going to say, I forgot my password. And you can see it found the password keyword and was able to figure out that that's the problem right away and give a knowledge article in this link right here. Now I'm going to show you what it looks like to go through the bot without using any keywords. So I'm going to wake the bot up again just by saying hi. I'm going to enter the name Able Tutor again. And it's going to say, how can I help you? So I'm just going to put in, I'm having an issue. So it responds with, sounds like you're experiencing an incident of some kind. What are you working on? So it prompts the user to go into a little bit more detail on the issue that they're having. I'm just going to say, it's with my email. And it picks up on that email keyword again, and it gives another prompt saying if you're unable to log in, unable to start the program, or just an error message with it. So I'm just going to put in, I can't log in. And it will respond with, so you're unable to log into your email. As you can see there, it found all the keywords that it needed to reach the end, and it was able to generate the report and send it to ServiceNow, as it says here. So now I'm going to show you what it looks like with the keyword pairing. I'm going to wake it up, put in the name, Able Tutor, and I'm just going to put in, I'm having an issue logging into my email. And as you can see, it gets the same response as it did with just going through each tree, each level individually. It's able to find all 3 keywords and make the report off of that. So now I'll switch over to the ServiceNow webpage that we have, the developer instance, and refresh the page. And you can see here that it was just created just now. And if you go in, you can see the name, the category being inquiry or help, with the subcategory of email. And down here, it's a short description based on the keywords that we found. In this case, it was incident, email, and login. And the full description is what the customer input from the start. So now I'm going to pass it off to Justin. He'll talk about the reports.
Thank you. So Andrew just showed you a little gist of what it looks like to, from the help desk's perspective, to see the ticket. The reason he said Able Tutor was his name was because that's already in ServiceNow, meaning the help desk agent will be able to grab Able's contact information, maybe his phone number or whatever, or his employee number, and be able to help him better with the issue. The category and subcategory were obviously assigned by the bot. Everything yellow up there was something that the bot provided to ServiceNow to help generate the ticket. Including the assignment group going to service desk, the contact type being web chat coming from a chatbot. The description could easily be changed to actually list the full conversation that the bot had with the user in case the categorization isn't working correctly for some reason. So the help desk would be able to look through the chat and say, okay, well, this is what the person meant, and then go through it and help them out. And this is what it actually looks like on the back end, the JSON data. As you can see, we use session data to hold everything. The reason for that is because we didn't use session data before, and when we tried running 2 bots at once, the data was actually getting mixed up between the 2, and then we Googled it, and apparently you're supposed to use session data for that. So we're using it for things like the user's name, the category the bot decides, a subcategory. A few of these are static. For instance, if you're communicating with the bot, the input type will always be a web chat. You're not going to be able to call the bot or something. And that's all I have to say about the reports. I'll hand it over to Brian to talk a bit more about embedding and Lewis.
Thank you. So basically, the end goal of embedding the chatbot is to get it to appear directly on Airtay's website. This could either be in the form of a tab that expands upward, a link to another window, or even just appearing right there in a simple iframe tag. But essentially, you just don't want the user to have to install Node, install the emulator, run the emulator from a console, and then get the help they need. So we did encounter a few struggles with trying to get this to work. Since we committed to a Microsoft product for building the actual bot, we had already limited ourselves in things that were compatible, that could host it or deploy it. After a few hours of research and trying to find out other resources, we did establish that Azure was our best bet. And in retrospect, we probably wanted to create this Azure registration first because it has all sorts of options for developing right there in the portal, but we still cannot actually upload any of our code. So that is what we're currently working on now. And It didn't help that we fell a little behind in this due to a recent loss of communication with a teammate. I am now starting from scratch with this because all progress was actually lost, but this is definitely a goal that we think will be completed that we can submit to Arete. Lewis, as mentioned before, is the AI aspect that we are looking into. This is the language understanding intelligence service also provided by Azure. Basically what this would do is make the chatbot very flexible and expandable, and it would make maintenance very easy in the future because it focuses on getting a user's intent based on their input. It would actually, a neat feature of this would be that any input it doesn't recognize, it would be placed in one large library of unrecognized input. And then a designated worker would go through, figure out what all these users are trying to say that it doesn't recognize, and make new entities that it does recognize. And so it's actually learning through experience. We did learn that this very clearly would cost some money down the road on a per usage basis. So Arete is interested in this implementation, but not certain at the moment. So as per Chris's request, we have just elected to make a high-level design document to show an overview of how it would work and what this chatbot would look like and if it is a better option for them. And now I'll hand it back to Jesse for some concluding thoughts.
So I'll start kind of with some issues and risks we had during this semester. The first issue we had was communication. As Brian said, we did lose contact with one team member during the last few weeks of the semester, and they were the ones working on embedding. And because of the way the embedding works, it's not like there's anything to upload on GitHub that we could just scrape from what they've made. So we had to start over with our knowledge of Azure and everything to kind of get the webbot or get the embedding working. Additionally, accountability was something we kind of had a problem with at first. For instance, we didn't make people show what they had gotten done in our group meetings, so we were just taking their word for it, and in some cases we exaggerated what we had done to each other in the group. So then later on in the later weeks, we were like, oh, I thought this was done, and it's like, well, this is 75% done. Later in the semester, we got all that cleared up, but that was definitely something we would do different from the start. Equal understanding was another big issue. Since I had a lot more experience with Node than the other people in the group, I started out working on the dialoguing and report generation. We originally thought that would only be something like 10 to 20% of the actual work, but as it turns out, that's basically the core of the actual bot itself. So not only did the other team members have to learn Node.js and Microsoft Bot Framework and all those things, but they also had to kind of interpret my own code base to see how I put stuff together and how they could extend functionality onto my system. Lastly, one risk was that it was very self-driven. On the positive side, it was really cool because basically all we got told by Chris was, here's what we want done, you can do it however you want, which is really cool because we got to choose exact frameworks we wanted, and we do think we made the right choice with frameworks. But on the flip side, that's a little bit less structure for support for stuff like Node.js and Microsoft Bot Builder, since we were supposed to be the experts on it. In that case, we had to rely on Stack Overflow and Wikipedia and stuff to figure out how that all works. And a few more post-mortem thoughts. We did a few things well. One of the big ones was regular communication with our sponsor. We had some ideas of what we wanted, and as we presented them to Chris, sometimes he said, that's not really what we're looking for, so we didn't waste time developing stuff that he didn't even want. Or if we missed something, he said, well, you guys aren't really talking much about this, and then we learned stuff that he actually wanted that we didn't get the first time we talked with him. Additionally, we got a lot of stuff done in the first half of the semester. That was really nice because as we had these embedding and communication issues, it kind of helped smooth out the average rate of getting stuff done. Although it would have been better if we would have been able to keep that streak going on, but we had to implement more complex things that took longer than just a dialogue. There are a few things we would change, one of them being more discrete goals earlier. For instance, one of our goals was develop the keyword pairing. I mean, that's very vague and a very big goal to have, and that's the end goal we wanted, but to have that as one goal is kind of unclear because then a person is working on that one goal for however long, and if they have the wrong idea, it will take a long time before we're able to correct that. A better goal might have been implement keyword pairing for this one part of the system, and then once we see that worked well, extend it to the rest of the system. like I said before, more accountability with checking each other's work and making sure everyone's getting stuff done. That would have been something we would change. The last thing we would change is more in-person group programming. For the first part of the semester, we did a lot more remote stuff like over GitHub and GroupMe and kind of communicating that way. And then in the last several weeks of the semester, we had more times where we're like, hey, let's just meet on Sunday, try and get some work done. In that case, we had a lot more feedback between each other, which helped get our ideas actually implemented faster and stop things that we didn't actually want to implement from happening. So just a few of the things, the technologies we learned. Node.js and Bot Framework go together, and then we learned how to make REST APIs on Node for ServiceNow to communicate with ServiceNow to send the reports to them. And some future steps we have, like Brian said, we're working on embedding the web page now. We're pretty confident about that, but in the case that we don't get it done, any future people working on this project, that would probably be priority number 1. The second priority would probably be more natural language processing. Right now, each of the branches on the decision tree only have 3 or 4 keywords, meaning if the user doesn't say one of those specific keywords, it might get lost in the bot and then it'll be a negative experience for the user. So adding more keywords to each branch would be very beneficial. Additionally, with Node.js, there's a lot of NPM packages for spell checking. So if the user misspells something, it can auto-correct it before sending it to the parsing part of the bot. And then even though they spelled a word wrong that was a keyword, the bot caught that, fixed the spelling mistake, and then processed it as they should have. Finally, implementing Lewis would help a lot with even preventing having to do so much work with natural language processing, because Lewis itself handles all of that stuff very nicely. So it would be a choice between the two. If you wanted to go with Lewis, you could probably skip a bit of the natural language processing work. But if you wanted to skip Lewis and not use Azure as much, just go straight into the natural language processing and try and fix that up. So that was all we had for today. We had a lot of fun working on this. We learned quite a lot. Did anyone have any final questions at all?
A couple.
Sure.
I know you kind of left it to say, okay, we're going to do this document, turn it over to Chris to say, do you want to do Lewis? Is that document good? Would you, if you were Chris, think pursuing Lewis is a good thing?
Yeah, it's definitely a good thing if you think that the net gain versus the net financial loss would be overall beneficial to the company, because I haven't found any weaknesses in it so far, except for the fact that if a lot of people use it, it just makes it more expensive because it is a per message basis. So that's really the only drawback I've found.
And then the other one, you said if you could get more relevant keywords would be good. Do you think you could automate finding those by going back through histories of previous calls? Automate that process. It says if I see this, I end up with that as a problem.
We could add a way for the bot to store words that were unable to be determined what they meant. There wouldn't really be a way to assign it to something automatically. That would have to have some human intervention of seeing what the user might have thought, because the bot can't really tell what the user thought, but that's more like a human instinct type of thing. If we use Lewis, as Brian said, it would really help a lot with that, since Lewis more easily captures these words that they don't understand the intent of and try and learn from them itself. So that's why we thought Lewis would be a better net benefit than working too hard on the actual language processing.
Thank you.
Cool.
Let's start us off. Hi, so we are the team that's been working with Rockwell Collins. The Rockwell Collins sponsors Michael and Casey, and then we are the team. I'm Lance Willett.
I'm Jordan Getz.
I'm Mitch Kalaji.
Clay Moody.
So what we'll briefly be going over is kind of an overview of what Rockwell is. the product that they've asked us to design for them, the proposed solution that they gave us, the schedule that we've followed, what our progress has been, and the status of the project currently going forward. We'll be going over some of the issues and risks that we faced, and then we'll go over some of the story points, how that played into the way the project went. A quick reflection over the project, and then what the next steps are. And then there'll be a question and answer section.
So Rockwell Collins is mainly an aircraft industry. They deal with commercial, business, and military aviation, and they also do work with airports. So the system that we mainly designed this for is for their FOMAX unit. It's an information management system being developed by Rockwell Collins. And right now the system is being field tested, and so is our application actually. And it'll help in debugging those potential units by potentially finding the bugs and such. Our application is useful because it helps save on time and personnel resources that would otherwise be spent transferring the data and sifting through it. Whereas our application helps allow those non-technical staff to be able to transfer those files using FTP, untarring those files, parsing them, displaying the data in a user-friendly way. And it also has a nice graphic for displaying the data and more easily spotting the errors in code. The proposed solution that we were given off the bat looked like this. As you can see, the teal area is kind of the file tree, orange area is the filter input, green area is the results table, and the pink area is the aggregated filter results for the graphing. And our midterm solution, this is a screenshot of it. We had the basic FTP file transfer. The file tree had some basic usability to it. The parser was operating pretty well, but it still was slow at times. And then displaying the filtered and parsed results in a tabular format. So we had to scroll through the graph. And then we also produced a Windows executable build that was easily run. And this is our schedule. It has some of the user stories that we did throughout this time. The green ones are ones that we all got done. The red ones are ones that we didn't quite get to. They were kind of the extras at the end. Some big ones are file tree quality of life improvements, results paging, and then a lot of updates to the graphing, making it a lot more user-friendly.
This is an overall, this is a picture of our overall application of where it is now. The file tree on the left, you can see some files are highlighted. You're able to open directories and close them again. We'll go over that more later. This is the filter results panel. It lists off the filtered results and their attributes in a box at the bottom of the screen. And then there is the graphing portion. It's in the top right of the application. It shows off basic functionality of that, and we'll go over it more in detail.
All right, so this is an example of the JSON configuration file. So each of these properties allows you to configure the application. So for example, a default path sets the default download directory when you FTP a file from a remote location to your local computer. The delimiter allows you to set the delimiter in each of the log files when we parse them. The fields allow you to set the name of a field and then the data type of a field in the log. So we can try to parse a datetime object as a date and time as a datetime object in Python. We can try to parse integers as integers so that later when we do our filtering, we can do filters that are intelligent to those sorts of data types. So like dates within a range or integers greater than a certain value. And then the sorting field sets like the default sorting. So when we sort all of the results after performing the filter, it sorts them by whatever, the name of whatever field is configured here. So we can just as easily set this to log level, and then all of the results would be sorted alphabetically by log level. And then a couple other properties. So here we have a demo of the file tree functionality. So in this demo, what we'll show you is we have no files loaded in the file tree. So we will go and we will open a local tarball file, and this will untar the files and extract them into the file tree. And now we can see that the file tree has been updated to include all those files that have been untarred. We can select individual files, or we can select a range. So selection is with right mouse. Selecting a range is you hold shift and you right click, and then you right click again, and it selects all files in between the two files that were selected. And then we can click apply filter to show all the data. Otherwise, if we double click a single file, it deselects everything except that one file and applies whatever filters entered into the bar in that. You have a question?
Hey, can you just kind of clarify a little bit more of the context and who's using this application and where this is deployed? I'm having trouble following that.
Yeah, so Rockwell Collins sends this product to potentially some of their customers who are working on using some of the new units that they're producing. And so in order to detect if there's been an issue with a unit, they get a whole tarball full of log files. And so this product basically allows them to parse through those log files, view the logs themselves in a tabular format versus reading through lines and lines of logs that are separated only by like an ampersand or a hashtag. So it gives a nice tabular format. And then also we can, as we'll show in a moment, we can use the graph to aggregate the number of results in a certain time span. So we can see if there's like been a large influx of events with a certain error code, for example.
Okay, thank you.
So what we showed you here was basically the control shift click, and then control clicking also selects an individual file. Control A and Control N, which were at the very end of that one. If you do Control A, it'll select every file in the current directory. If you do Control N, it'll unselect all files. So those were some of the quality of life updates that Mitch had mentioned before for the file tree. Here we have a demo of the basic FTP file transfer. So we'll get this one started. So for this one, what we will do is we will go up to the upper left corner of the application, and we will select File, and then there will be an Open Remote option. Here we paste in a FTP test site. The site provides just some demo zip files that you can download. And then it has dialog boxes for connecting to the server, and then it shows the progress as it downloads each file and attempts to extract it. Because of the fact that this site is just for testing if a FTP connection is working, all of the zip files are empty, so when we extract them, there's actually no files in them, so it doesn't produce anything. But at the end of the extraction phase, or download and extraction phase, we'll see that the file tree is updated with the files that have been downloaded into the download directory. And in an ideal situation, there would be content in those zip files, and that would then also be displayed in the File Explorer. So we'll skip this along a little bit. And you can see up there that all of the files have now been populated into the file tree. And so this would be useful for, instead of having to manually email log files, you can just make them available over an FTP server, and someone who's using the application could then download them with the application and have them automatically extracted. We have a demo with the parser, filter, and filter results. So in this case, you can write a Python expression with some syntactic sugar, which allows you to perform several different kinds of date filters and value filters, which then parse through each of the lines in these logs that we've selected, and then display the results below in the results section. So here we apply a filter, and it's parsing through all the files, and then when it completes, it populates the lower section with all of the log lines that match the given filter. So in this case, we have a date filter, so basically anything that has been created beyond a certain date is shown by this filter. In this case, we also clear the filter to show pagination, so you can, it shows about 5,000 results per page, and then we can paginate through each of the, I think this total query at the bottom, it looks like it has several thousand results. So we can paginate through each of those. Then we can do different sorts of filters. So this is like a string in another filter, and then we can save the filter, give it a name, which we're doing with this pop-up box. So basically, if worn is in the log level message field, then we can close the application, reopen it, and in this drop-down box on the lower right, we can actually load that saved filter. So this will allow, and this saves it to a filters.dat file, which then can be distributed with the application to provide some basic filters for the people who are using the application. We can also change the name and edit the filters as well as delete them, which you'll see here. So here we're checking to see if error is in the log level instead of worn. And then in this case, we'll now delete the filter by clicking the delete button. And it's now gone. And this final one is a cool feature where you can right click on any of the results in the filter results and then click show surrounding, and it will let you basically create a date filter from that log message to some time interval before or after and show all log messages surrounding. So this is, say, you have a critical error, you want to see what was happening so much time before and so much time after to help with troubleshooting.
And yeah, then here we'll be showing a video of how the graphing functions work. First, you'll see that we have a file selected already, and we will filter is applied, and we'll add them to the graph, plotting each of the points out. This is a 10-minute aggregation, I believe, for each of the results. And then we will apply a new filter with different selected files. Add those to the graph. You can see it's a different plot. That way you can compare them. This is the zooming function, and able to pan around on the graph just to get a better view of different data plots. This is the changing of the aggregate of the graph. When we click OK, it'll reapply the last filtered results, and then it will also reset the graph so it zooms in on them. And then here we'll be showing that if you click on a plot on the graph, it will apply a new filter into the bottom of the filtered results of the points that were specifically in that aggregate of the graph.
Yeah, so basically how aggregation works is starting at the first date in the log, every certain aggregation time period. So in the first plot that was showed, it was 10 minutes. So every 10 minutes, we aggregate all of the number of occurrences of that, of whatever's filtered into one point and count basically the number of occurrences. And then so you can configure that. So the second one, it changed it so it was showing it aggregation of every 5 seconds, which is why it looked like very blurry because there were so many points. And then the last one was every hour. So you can see what events happened in that hour and how many events happened in that hour.
So some of the issues and risks that we faced when carrying out the project, initially the big issue was how are you going to parse, filter, and display up to 60 gigabytes of data? It's a big issue. Essentially what we did was we kind of broke it down using the way the files are parsed and filtered, so you don't have all 60 gigabytes in memory at any given time. And then later on, the issues were mostly revolving field testing. As the application became more useful, new use cases came up, different issues that weren't, in the product before became apparent, and we had unforeseen data irregularities where the test data we were using wasn't fully inclusive of all the different types of data we would be getting from actual log files.
A good example of that too is if you just go into the file directory and you do Control-A, it'll select a couple of files like a DHCP config that outputs logs in a different format than all of the other logs. So there's some irregularities with trying to parse that if there are not the same number of columns. It can't parse it the same way it would all the other files. So.
And then we also faced issues with testing, filtering syntax.
So that's just like irregularities with like what happens if we add several date filters and too many parentheses sometimes, because we had to write a lot of the expression evaluation is done by the Python eval function, but then also a lot of it is done by manually parsing some of the queries and removing and breaking up unneeded like clauses.
For the sprint analysis, for our third story, you'll see that we estimated 27 user story points, and we completed 50, and that's just showing how many ended up getting added after we initially estimated what we were going to be working on and what we ended up doing. Actually, same goes for sprint 4, where we started with the 27 and ended up with 34.
So looking back, there are some things that we would have done differently. Big one is split up tasks more evenly between different group members. We would have found a better hosting solution for our source control. What we ended up using was a GitLab set up on a Raspberry Pi in Jordan's apartment, which was not always reliable. We had to find some workarounds for that because it kept crashing. Time management obviously could have been done better. And then keeping up with the documentation. Anytime you add something to the project, be sure to add it to the documentation concurrently. Things that went well, as you could see on one of the earlier slides, we implemented almost all the features that we intended to implement, all except 2. And this was done partially because we chose well-documented libraries, WXPython, matplotlib, very well documented, easy to extend, and we handled the addition of new story points as they came up efficiently, and we're able to kind of roll with the punches on those. So the next steps for us are to hand off the application fully to Casey's team. They'll be testing it. They have the latest build now and are using it, and they have already come up with some bugs that we didn't see coming that we've last minute been able to fix. And we have provided them with the source code and instructions on how to build, so they are able to extend it from here.
Any questions?
I guess other than the few things you kind of mentioned that had been identified that hadn't been implemented, were there any other big features, or is this something that's mostly feature complete, get the bugs fixed, and it's kind of just needs periodic maintenance, or is there even a next phase beyond this?
A lot of the use cases that were come up with were basically ones that we would have a meeting. There was actually one week where Mike was gone, and Casey just had a whole bunch of ideas that he requested of us. And then it was kind of, as we go along, he would come up with new things that'd be, hey, this would be useful if it were to do this as well. So there isn't, we haven't, he's missed a couple of meetings because he's been traveling due to working on this product that this application is supposed to help with. And so we haven't had direct meetings with him in a while. However, from the sounds of it, he's been testing it, and he's optimistic that any additions they should be able to figure out and add themselves. And that right now just getting it basically stable is more of a priority than adding new features.
This is going to be sent out to users?
I believe it was supposed to be to basically Casey's internal team, as well as partners that they work directly with for debugging some of these units.
So given that it's going out to partners and people, is there a need, or did you build a user manual?
Yes.
Yep. One of the things that Casey especially stressed early on and throughout the entire process was this will be used by a lot of non-engineer type people, is the terminology he used. So it had to be straightforward, and if you plop someone down in front of it, they have to be able to go from no knowledge of anything about how it works to being able to use it to troubleshoot, complicated problems with aircraft.
Yep. So he had us write some ASCII doc documentation that then Casey said he has a script that builds it all into a nice PDF that they can distribute with the application.
guess it's not something that capstone teams usually do, but had there kind of been any usability studies where at some point, or maybe even just now, hey, let's hand this over to one of these non-technical people and see how long does it take before they can do something, or they maybe already know what the problem is, but how long does it take them to use the tool to arrive at that?
I don't know if we've been made aware of that, but I know that Casey has been testing it the last couple days with some people on his team and sent like 5 bugs that he found yesterday that we got fixed. So, any other questions? All right. Well,
Thank you.
Thank you.
Hello, we are the Microsoft Group. I'm Zachary D'Ambrosio.
My name is Alan Pulis.
I'm Ben Weller.
I'm Eric Van Aspen.
I'm Akil.
Our project is the Pizza Oven Monitor for preventive and reactionary maintenance. So just a quick overview of the company we're working for, Microsoft, in case you don't know anything about them. They make Windows software, Dynamics, which is a business analytics tool, and Azure, which is a cloud-based computing tool, and Office 365, which has your things like Windows and Excel and all that stuff. Within Microsoft itself, our mentor is Dave Frostley, who works within Dynamics 365. So moving on to what our actual project is, it's proof of concept, and that's about connecting various technologies and seeing how that goes. And so the scenario that we're using to test that is pizza ovens that are internet connected. So they send their data somewhere, and you use that to go through the data and find red flags for preventative maintenance. So you know, like certain things about the oven. So maybe the temperature is rising slower. Maybe that's a sign you need to do something about it. So the big problem that this causes is you're going to want to move the data around a lot. You're going to want to provide it to different people, and you're going to want to always have access to it so you can keep making your red flags as accurate as possible. So that causes problems of moving data around a lot. You might get some inconsistencies, you might cause some errors, and if you're moving it around like that, that's going to be trust issues too, and you want to avoid those things. So what we want to do is we want to find a solution that allows us to tackle those problems, make sure it's scalable, because with a lot of components you might end up not letting it be scalable, which is obviously something you want to avoid. And we also want it to be accessed through a mobile application for like the manager or whoever needs the information about the oven for ease of access. So for our solution itself, what we decided the best option was we wanted to use largely based around using Azure, and what that provides is it provides a number of options for like the notification hub on Azure and the IoT hub, which allows you to easily integrate things like our mobile aspect and the IoT aspect right into Azure. And then for the data problem, we decided the best option was to use, a blockchain, which I'll let Eric go into more about why that works really well, but basically it solves our problems of trust and access. And then if we look at our diagram, you can see that coming out of the Raspberry Pi, which is the IoT device, it has a hot path and a cold path. The cold path is the blue one, and that represents non-consistent flow of data, and also where you're going to be storing all your data. And the hot path is more consistent flow, and it's much quicker, and it's directly to the mobile client, so that way they can get their information as quickly as possible. So as you can see, it kind of covers both if you need to tell the mobile client immediately and storing the data so you can go over it later. With that, I will pass it on to Ben to talk about our schedule.
So regarding our project, Sprint 1 started off, met everybody, met Dave, talked with him about the project. At this point, we weren't really sure where the project was going to go, and we knew we needed to pick a blockchain. So we picked Ethereum initially. We switched that later on. I'm sure Eric will go into some reasoning behind that. That was pretty much Sprint 1. Moving on to Sprint 2, so the second month, the IoT portion was added. So Akil initially wasn't a part of the team, and so he joined, and the IoT portion, which was initially deprioritized, became reprioritized. And we made our first trial application for our mobile app. This took an entire month due to some issues with Xamarin that I'm sure Alan will get into. And lastly, we chose to switch from Ethereum to Hyperledger Fabric. Again, I'll let Eric talk about that. Moving on to Sprint 3, we had to ensure that we were able to create dynamic notifications. So we did that. I created a Node.js script that allowed us to send dynamic notifications. Then we set up our Hyperledger development environment locally. And then moving on to Sprint 4, we built a web server that had a web API so that we could send it some JSON and it would produce a dynamic notification. And so any component in our system would be able to call that and create a notification. Lastly, we attempted to rebuild the Hyperledger Fabric environment on Azure. That didn't go so hot, so we'll get into that later. Moving on, I'm just going to briefly touch on progress here for our mobile app. You'll see up at the top left there, I have a Postman client open. So this is running a post to our URL, and this will send a notification, as you can see on the next right two pictures. So we get a notification, and it contains the message that we initially sent to our web API. I'm going to pass it along to Eric to talk along the blockchain.
All right, so as far as the blockchain goes, a lot of people aren't really familiar with it, so we're going to cover some bullet points before we actually get into the progress here. So as you can see from the slide there, I've got about 4 questions we want to answer, and then we'll get back into it, because it makes a lot more sense when you actually know what you're dealing with. So what is blockchain? As you see from the slide, it's a string of buzzwords, and that's generally how it works. But no, realistically, it's like an over-engineered database, more or less. So there is a database at the very back end of it, except there is a lot of permissions, a lot of validation, a lot of networking that goes into basically the building of a blockchain. So that's what sets it apart. Any kind of data that's put into the blockchain has to be validated by every other peer that is a member of that blockchain. And if they don't validate it, it doesn't go on. If they do validate it, it's time-stamped, logged. Basically, you know, generically, you know who did it. So there's different types of blockchains, and we'll go into that in a further slide here. But in general, you know who did it, and then when they did it and what they changed. So as you can read on the slide, it's decentralized, distributed, more buzzwords and things of that nature. Everybody's got to validate. That's basically a blockchain. So how does it work? So as with anything technological in this world, people like to give it weird names so that it doesn't make sense to the common folk. In this instance, a transaction, which could be anything from money, could be data, could be physical assets, things of that nature, those are called blocks. It gets sent to basically a network. Those networks are individual nodes. So in different implementations, you have different node layouts. So we'll get into that in a different slide as well. Once the transaction's on a node, it needs to be verified by every other node on the network. Once the verification happens, that transaction becomes immutable. Pretty much all the data that's on that transaction will stay. So you can change the data in the future, but that transaction you made will always be viewable. You can always go back and query that information, see who made this transaction, what data did they change, all that fun stuff. So that's pretty much how it works. And then why blockchain? So when you're thinking about blockchain, you're probably thinking about people, oh man, I made my millions on Bitcoin, right? Why does a business care, right? They make money other ways. So the reason it matters for a business is mainly trust issues. So the way that businesses are currently structured, everybody has their own database. So everybody has to maintain their own database. There's overhead in technical costs that come along with that. And also, if you have a discrepancy between two entities' data, you're always going to have at least one unhappy individual. So nobody trusts anybody. Whoever's on the losing end of that discrepancy is always going to be rather upset, and they want to know why there's a discrepancy and who's at fault, and are they really the one that's at fault there? So that's why the blockchain helps having a distributed ledger on a blockchain, everybody has all the same data. As soon as a transaction is pushed through the blockchain, that data is distributed to the ledgers, and basically everybody agreed. So all the nodes, all the companies, they all agreed that that data was good. And if there was some kind of shenanigans going on there, they can go back, they see the timestamp, they see that Bob from company A did this on day A, he changed exactly this information, and then he can be held accountable for that. So now we get to the which blockchain part. So I'm not sure if you're all familiar, there's an entire stock market on blockchains. There are hundreds of these things. Two different types of blockchains in general. There's the public and the private. In general, your public blockchains are going to be things that have a cryptocurrency tied to them. They are mainly for financial transactions, although things like Ethereum, they kind of branch out. The private blockchains, they're more for enterprise data and things of that nature. So the main difference between them, a public blockchain that's tied to a cryptocurrency is in general going to have a fee associated with every transaction. So when we went with Ethereum to begin, the reason we went with that is because there's a lot of documentation. It's been out for quite a while, and basically it seemed pretty simple. And then we got into it and we noticed, okay, you have to pay a fee for every single transaction, and it's just some fraction with Ethereum, for example, of Ether, but it's still like $3 per transaction, and you have to mine this in order to actually do it. So what we would have had to do is fork the coin, make our own cryptocurrency, and then we would still have the very first transaction, you would have to pay the Ether to acquire our coins, which we could give you 1 trillion coins and you would never run out. But you still need the Ether for that first transaction. So that was a pain in the butt, and then, what if somebody happens to do 1 trillion transactions? They're out of coins. You need to re-up the coins. It just became kind of a pain in the butt. So we ended up going to Hyperledger. Hyperledger we really didn't know a whole lot about. So Dave was nice enough to kind of point us in that direction, and as it turns out, Hyperledger is a much better fit for this particular application. Reason being is it was built from the ground up for business applications. There is a business modeling language that they built for it, so you can have basically 3 tiers of users on it. So you can have your business users who like their reports and analytics. You can have your network administrators who divvy out rights, and then you can have your DevOps folks who set everything up and make sure it's running right and things of that nature. And they support test environments for all 3 of those, but that's also what causes a lot of complications. So we had a couple of criteria. First off, the blockchain had to be on Azure. So one of the big things with Azure is scalability. A blockchain on Azure is very nice and very scalable, simply because every company needs nodes. So basically you have 4 nodes for a minimum on a Hyperledger blockchain. Any company or entity that wants there to be included is going to need that 4-node minimum as well. And then as traffic increases, you can scale up the nodes to handle the traffic. So it's a very nice implementation. But basically we needed, again, to have it supported on Azure. So Ethereum was the main supported blockchain on Azure, which again, we were kind of ignorant in the beginning. We didn't know the terminology. And when I was searching for these things, I wasn't reading news articles, I was reading documentation. And of course, no documentation is going to point at the other guy and be like, oh, he's great for this application. So when I started, I thought everything was a cryptocurrency tied blockchain. So ignorance was a big part of why this didn't come together in the end. But moving on to the progress, so the first sprint, of course, we started with Ethereum. That didn't pan out because, again, the implementation just doesn't work. There are people that are trying to get it to work. It's just kind of sloppy compared to other implementations. So that took a fairly decent amount of time, about a month, to figure out that we really are not going down the right path here. So we switched over to Hyperledger at that point, and then we deployed the 4 nodes on Azure. The Azure implementation was actually very simple to set up, although getting everything set up and then moved into Azure from the outside is not so easy. But on Azure, you have the 4 nodes, so you can see 3 of them there. You have the client, the orderer, and the peer. You have 2 peers per setup. So that's where your 4 nodes come from. The peers are what hold the chain code, which is basically what tells you, all right, these items need to change. It's basically where your scripts are held and executed, and the peers are also what come together and make a consensus to give, whether the chain code you're validating is valid or whether you need to throw it away. So we created the business model file. Basically, to do that, we had to set up an entire development environment, like I mentioned previously. Hyperledger has a suite for basically 3 levels of business employees, and you have to go through every one of those levels in these files. So the model file, the .cto, is actually a modeling file, so that's what the business analysts would use. They would basically say, all right, here, well, they probably wouldn't write it, but they would have a lot of input in there. They'd say, all right, we're dealing with these businesses, we want the data to be structured this way, and things of that nature, so that eventually that could be sent off to analytics and they could generate reports and things of that nature. So that model file directly correlates to the chain code file, which is a JavaScript file. That JavaScript basically does everything in a transaction. So if you need to transfer ownership rights from item to item, you would be in that JavaScript file. If you need to change data, if you need to do anything, it's going to be in that JavaScript file. And also the permissions file is obviously permissions. So Hyperledger is different than the public blockchain. In that public blockchains, you anonymously just make a transaction. It doesn't care who you are, it doesn't validate anything. If you have the setup and you submit a transaction, it's pretty much good to go. Whereas with this public block or the private blockchain here, you need the permissions because you can have different levels of users. Say you want Cindy from company B, right? Cindy is a filing individual. She does paperwork, things of that nature. She doesn't need to see the financials. She doesn't need to see various portions of this data. So you give her the permissions that you want her to see this. You want her to have right access to that type of thing. So in the end, we failed to deploy the BNA file, so it's a business network file, to the peer nodes. Reason being, to get to the point where you actually generate the business file, it's actually a rather long road. So like I mentioned, you need an actual development environment. Started out trying to install it on Windows, did not go well. It is made by the Hyperledger is a project by the Linux Foundation, so of course Linux integration would be easier. Me having some 10 years of IT experience, no problem, right? I can get it working on anything. Not so much so. So ended up wasting some time on that, then porting it over to Linux, ran a lot better there. Problem with that is, at some point, so we had to rebuild this development environment twice. The reason we had to rebuild it, we had it on a local environment, so I have a Linux machine, so it was just on that. We were developing things, we got the BNA file all set up, and we couldn't migrate it to our production, which was the Azure nodes. Reason for that, Hyperledger is fairly new. It's some 7 or 8 months old, I want to say, and they update things all the time. So basically what ended up happening is our chain code wasn't compatible with our dev environment. Somewhere between then and now, the dev environment was upgraded to a point where the chain code examples that we were using to model this weren't compatible with our version of Hyperledger anymore. So we switched over to Azure, basically got that set up and fixed the issue, but we ran into another issue that wasn't in the documentation, and at this point the documentation had been migrated, so they either changed hosts or they did something. But their GitHub account, as well as their general documentation, their website, pretty much everything that I had bookmarked or that I knew about was now leading to null sites. So they switched all, had a big hullabaloo trying to find everything again. But basically, at the end, there are shell scripts. Those shell scripts do a lot of setup for each individual node because you need the IPs, the ports, the login credentials, etc., to actually get the chain code to run. And needless to say, kind of ran out of time at that point. So I pretty much mismanaged my time, invested a lot more time than I should trying to get this finished, and had a bunch of homework piled up. Basically shot myself in the foot there. So Moving on, we'll move to a Keel here and the Internet of Things implementation.
So coming to the IoT part, we have a couple of hardware devices that we have actually used over here. So the first thing is the Raspberry Pi. As you all know, it's a microprocessor, and Raspberry Pi is one of the best microprocessors employed for the IoT applications, and given its processing speed. And we, on the other hand, we have a temperature sensor, a DXE11 temperature sensor that actually detects the temperature and humidity. And whatever data is gathered by the DXE11 is sent to Raspberry Pi, which processes it. And and then we like store all the gathered data in the cloud, which will be seen in the further slides. Okay, so first of all, we generate the device credentials, and so device in specific is the DXE11 over here, and each device of course has a device ID and device key, which these two parameters vary from one device to the another device, and these two parameters will of course be used in the further operations that we actually worked on. So we were able to gather data temperature from the DXE11 and send to Raspberry Pi, and after processing we were able to store all the data on the Azure platform. And so whatever data was gathered by the DXE11 and processed by the Raspberry Pi was stored on the Azure, and we actually got it stored in the form of table. We could also store it in the form of a file or a queue. And so as you can see over here, we have a range of temperature values which are detected by the DXE11, and we also have a threshold value which was initialized to 30 degrees centigrade, and if the temperature was supposed to exceed 30 degrees centigrade, it was an error. We were supposed to display an error. So as of now, we have a list of temperature values detected by DXE11, and also a temperature value which is crossing that specified threshold. And instantly there is an error which is displayed, which is the temperature alert, saying that the temperature is too high. And so yes, so irrespective of whether the temperature exceeds that specified threshold or not, all the gathered data is stored on the Azure platform. And in case we have any value that exceeds the temperature threshold, we have push notification to be sent to the Xamarin. We were supposed to have that, but unfortunately we failed in actually we were not successful in implementing that part. So yes, I'll now pass it on to Alan.
As we move on to the issues and risks coming into this project, there's quite a few of technologies that we're not aware of at the time. We didn't have too much domain exposure. Azure Portal was fairly new and complicated at first until we actually got into it and started playing around with it. Xamarin, it's an awesome technology. It's cross-platform, so you can create on iOS or Android or Windows Phone. But we ran into some early issues with building just a simple app, or even getting the right emulator for that specific build. So there's quite a few times like we were trying to play around and uninstall or reinstall emulators, or go to a different Android that we were actually working on, like either go to Oreo or move down to Nougat. So after we eventually got over with that, and we were able to build our app and work on that. And also blockchain, its limited documentation regarding the Hyperledger fabric, which gave Eric some issues with that. Also, I want to talk about the Azure access. Microsoft has a 1 month free $200 subscription that you could rack up and use and play around with Azure and create different stuff. But just because our project was semester long, we couldn't really use that, because then we would have expenses on our part, and that's not really what we were aiming for. But our mentor Dave actually got a subscription for us, and we were able to build and deploy stuff on that account. So just some postmortem summary. We realized that research is super helpful, and done right can lead to success. Understanding the concept is not enough. You need to know where to find it. So documentation is always helpful. Watching tutorials and implementing on what that person did on the tutorial to our own specific needs and being able to adjust accordingly, and also ask for help. Like if you are can deploy something or can't get to work, ask for a new or just a fresh mind or a new set of ideas that can actually help and help the project go forward. And this diagram at the bottom of the screen, it's our current architecture that we have at the moment. Since we weren't able to get the IoT portion implemented with the project, we have a similar device that reads a certain number of values and then calls a function that calls the API. So if we had more time, we would like to implement, of course, a hybrid ledger fabric, because I think that's the backbone of our project, being able to exchange secure data from the businesses all the time. We would like to upgrade our mobile application so the user interface is not so plain just to receive a notification. So the project manager or let's say the pizza store manager can go in and be able to manipulate some data. And also we would like to implement the IoT device, since it's an awesome technology where you could just have different devices that read different temperatures and it all comes back and be connected on Azure. And that concludes our project. If you have any questions, we'll be happy to answer them.
I'm trying to absorb everything, but okay, so the blockchain, I kind of understand the issues there. And I guess on the front end, the hardware isn't working or something? So
the hardware is actually working, but we were not able to pretty much, integrate the IoT part and the examining part.
Okay, those parts never got.
Yep.
Because I didn't see the prototype of the mobile app either. Was there something built on using Xamarin that was showable?
It's on my phone. We just didn't want to fire up the document, and we were initially intending to have the IoT device sense the temperature beyond 30 degrees centigrade and then fire off a request to the web API that I've set up. That just didn't happen, so we just kind of scrapped our demo.
There is a demo of the blockchain portion if you want to see it, but see that we're kind of shooting the time here, so.
Thank you.
Center group. We built an Eiffel Jira plugin. My name is Brandon Rudisell. With me are my teammates Jaden Young, Brett Connect, and Brendan Curran. Little introduction. Our sponsor is Software Center. More specifically, we've been working with Linköping University. Our contact there is Ulla Liefler. Towards the end of the semester, we discovered the true pronunciation of his name is actually Ulla Liefler, and we had been calling him Ulla the whole time, which, as we now know, is a woman's name. The other option is Ola, which is something far worse. With him, we worked with his PhD student, Azim Ahmad, and another contact, Daniel Schall, with Ericsson Telecommunications. Now, Software Center is not just one entity alone. As we already discussed, there's also universities involved with it, and other European, mostly Scandinavian companies, such as Volvo, Saab, Bosch, and Siemens. Software Center's mission statement, off of their homepage, is to work together to accelerate the adoption of novel approaches to software engineering. One of those novel approaches is the Eiffel Framework. The Eiffel Framework enables technology-agnostic enterprise-scale continuous integration and delivery with maintained scalability, flexibility, and traceability. But what does that mean? It means that Eiffel allows for heterogeneous tools to work harmoniously in a work environment. This would allow continuous integration softwares such as Garrett and Jenkins, or version control such as GitHub, GitLab, Bitbucket, or SVN, Subversion, to work together, creating a small layer on top of them of a shared vocabulary. This is something that I've faced personally in my actual work. Some projects using GitLab and then transferring to, say, Bitbucket, as well as some projects using Subversion. Eiffel aims to allow developers to use whatever software tools they please. Eiffel is licensed under Apache 2.0. The problem that we were faced with is that they wanted Eiffel to have a means to receive Jira events, a plugin for Jira. This was in an effort to expand the library of compatible softwares for Eiffel. Along the way, we also introduced new events into the Eiffel framework.
So our solution to approach this problem was to use the Jira webhook API. The main reason we chose this is because for Jira there are two main ways to host Jira. One is on a local server, your own server. The other one is through a cloud-based system. The Jira webhook API would allow us to interact with both of them. Our plugin catches information being deployed to a URL that you choose. We're listening for the blobs of information to come in. We process that and then ship it off over RabbitMQ to Eiffel. For the first two sprints, we made contact with the Eiffel community and began our collaboration with them. We prototyped an implementation to get a feel for what it is we were after. We began iterative design with the community's input. Through this iterative design, we identified a few dependencies, mainly validation and a persistence solution. The problem here is they weren't well defined. We wanted to move them out to a more accessible location for additional plugins later on, so it wasn't being reinvented each time. For Sprint 3 and 4, we continued our discussion with the Eiffel community. We edited some proposed changes as they came about. We defined changes, and they're currently in the process of being merged. We have a pull request out for the repository. Additionally, we have some other event types that aren't currently approved that we're hoping to have pushed in, but we're waiting to hear back on those.
Alrighty. So, where are we now? What have we done? Kind of story of our project is then there's been two threads, really. There's been software that we've written, but we're not really sure what we want it to do in the end, right? Because there's the Eiffel protocol, which is a separate entity. A little bit of history is that the telecom Ericsson actually internally developed this protocol and then later decided to open source it. But in the process of open sourcing the protocol, they've gone through pretty much a total rewrite. And really it's a protocol that specifies this is the structure of, say, what happens when a source control system issues a commit. And it looks like this blob of JSON. This is where you put your fields in. Now all your systems can talk to each other. One of the issues we ran into was that its slated purpose was really more in the CI/CD land, continuous integration, continuous delivery, and not so much with issue management. If any of you guys have used things like GitHub or Jira, a lot of times you notice that there's special syntax you can use in commit message, where if you do like a little hash and a number, it'll link back to the issue in your particular issue tracker that's integrated with that. And so there was a notion of that in the Eiffel protocol already, but we wanted to expand that out. So we expanded that out into its own first-class identity. as a issue defined event. That right now has been accepted into the Eiffel protocol. The other two things we wanted to add were issues statuses being modified, transitioning from states of being open or closed, anywhere in between, and also having a way to say that an issue has been assigned to a particular person so that you can trace back, this is when an issue started, this is all the work that's been done with it, these are all the test case executions that happened everywhere towards it. But as they say, a picture's worth 1,000 words. So we do have a little demo. Let's say if we come here, normal Jira workflow, let's make a new task. We can create it here. And if we look over at our RabbitMQ, very squished, we can see that we got a blob of JSON in Eiffel language, in Eiffel speak, that has a little bit of information about it. We can also go back to that one, lost. We also do have functionality currently for issues being assigned and for being marked as in progress. If we go back, we can see it. Same thing for assigned, if I did want to go through and get that. But yeah, that should be good. In the interest of brevity, we will not, there it is, dwell on that too long.
For issues and risks, one of our issues was, one of our stretch goals was to integrate our proposed event types into the visualization software. Unfortunately, the visualization software targeted an old version of the protocol, so we weren't able to actually achieve that stretch goal. And then risks, we always ran the risk of our proposed additions not being accepted into the protocol. Post-mortem, what went well was our implementation of the software. We got it working. And then our interaction with the Eiffel community. Our topic, our thread on the forum about in the Eiffel Google group is the most read and discussed topic within the community by quite a bit, which is pretty cool. What didn't go well, we weren't able to reach our stretch goals, and we wished we would have fully integrated the visualization of our project. Next steps would be to integrate the plugin into the visualization program, and then also write up an outline of existing issues to pass on to the next team to take this project. We need to record reference material for Software Center, kind of going over what we did, and then our final debrief meeting with our sponsors. Any questions?
I have a question. So where you're at right now with your goals, am I right in understanding that you can take a Jira event, send it with the correct Eiffel protocol in a JSON file to any other subversion control, and it will take that data from the JSON and use it correctly?
Yeah, so kind of the big central tenet of the architecture of Eiffel system is that they've really kind of centered around using RabbitMQ as a message broker. So we take that blob of JSON in Jira speak, transform it into a corresponding Eiffel event, and send that off to RabbitMQ. Whoever chooses...
From RabbitMQ now?
Yeah, it can be taken straight off of RabbitMQ. That's the visualization software right now. It takes events from RabbitMQ, and you just take the JSON blob, do what you will with it. That's, and without getting too much into message brokers, the kind of delineation of responsibility is it's there, and then whoever wants to take it can. But yes, that does work.
So in the future, would you have, what's your thinking about having capstone projects that are sort of dependent on open source community responding? Is there time frame issues that just we shouldn't be doing that?
I think probably the biggest issue is just that we came in at such an early stage in the Eiffel community, in that the protocol is still evolving rapidly, so we don't know exactly what we're trying to produce in the end. And also there hasn't really been, or at least there wasn't, an idea of an architecture, a shared, not really a diagram, but just this idea of whose responsibilities are what, where the lines between actors are drawn. And that was one thing we spent a lot of time on, going back and forth with the community. And actually our discussions resulted in the creation of a new repository with lots of cool diagrams and things about this is what this person does, this is what this system does, this is what you should concern yourself with.
I would add to that an open source project requires a lot of communication with the community, and that the community members for our project were at a 7-hour difference to us, and that can make for a lot of lost time waiting for a response.
And then knowing all this going into it, I think would have been a little bit more help. I personally have no experience with open source communities, so knowing that how this worked would have made the learning curve a little bit easier for me personally. Any other questions?
Is there any licensing hurdles or anything we had to do for the open source?
Fortunately, everything's Apache 2. Everything that we've touched. We haven't run into any other particular issues.
Just to kind of follow up on the open source angle again, since this is something where it's an open community, are any of you kind of planning on maybe continuing on with this over the summer or going forward, or are you just kind of out at this point?
We do have a one final meeting with our sponsor on I think it's May 16th. So I mean that's the summer, but I'm personally done with computer science after May 12th.
I think there are a couple little tiny things that I want to add, want to get done.
Thank you.
Awesome.